Alright, in this video we're going to look at how we can determine empirical formulas given a set of experimental data. Alright, so I'm not going to read through all of these instructions, but I'm going to demonstrate them as we go through an example problem. What you might want to do is pause the video, go ahead and write these down, and then you can sort of follow along or check these different steps off as we work the example problem. Alright, so we're told that a laboratory analysis of aspirin determined the mass percent composition of the elements in that compound. And we see that aspirin is 60% carbon by mass, 4.48% hydrogen by mass, and 35.53% oxygen by mass. And this is pretty typical. We're very often given the percentages of each element by mass in the sample when we want to find the empirical formula. And by far the easiest thing to do is assume that we have 100 grams total of the compound. Because what that means then, if I have 100 grams total of aspirin, then I have 60 grams of carbon, 4.48 grams of hydrogen, and 35.53 grams of oxygen. And an empirical formula tells us the ratio of each atom in the compound, but it also tells us the ratio of the moles of each element in the compound. And so, if I can find the ratios of the moles, I'll have the formula. And I know that I can go from mass to moles using the molar mass of each element. So if I know that out of 100 grams total, then I have 60 grams of carbon, 4.48 grams of hydrogen, and 35.53 grams of oxygen. Now sometimes in these problems, they just give you the masses straight away. And so in that case, you don't have to do any assuming, just work with the masses that they give you. Alright, and so then for each element, I want to convert those masses into moles. And so for each element, so for carbon, to convert to moles, I need to divide by the molar mass. Alright, so that gives me 5.00 moles of carbon. Now, just a word of caution, at the end we're going to round to whole numbers, but don't round too early or you'll mess up your calculations. Keep at least 3, maybe 4 significant figures as you're working through these problems. Alright, for hydrogen we'll do the same thing. And then the same thing for oxygen. Alright, so the empirical formula tells us the ratio of the moles of each atom. And so to get a ratio, I needed to divide. And so I want the simplest whole number ratio. So what we want to do is whichever element I have the least moles of, in this case it's oxygen, take all of the elements in my compound and divide their moles by the moles of the least one. And so then in my formula, it'll end up with 1 oxygen, and it'll tell me how many carbons and hydrogens I have relative to 1 oxygen. So divide that by 2.22, divide that by 2.22, and divide the oxygen by 2.22. And so when I do that, I end up with, 1 oxygen. Right? The hydrogens, 4.44 divided by 2.22. For every 1 oxygen, this means I have 2 hydrogens. And when I do the same thing for carbon, I get 2.25. Alright, now sometimes we're done at this point. If we get all whole numbers at this point, or close to whole numbers, then we can assume that that's the formula, right? But I wouldn't write the formula where I have C 2.25. This needs to be a whole number. And so this is not uncommon, and it just means that we have an odd number of carbon atoms relative to the number of oxygen atoms. When we get to a situation like this, it's always going to be a clear fraction, right? 0.25 is like a quarter, or it might be 0.333, like 1/3, or it might be 0.5, like a half, or it might be 0.75, like 3/4. And so if we think about this as being a fraction, whatever the denominator of that fraction is, if I multiply all the numbers by that denominator, I'll get whole numbers, and it'll be the smallest whole number ratio. So here I have 2 1/4. So to make that a whole number, I would need to multiply this by 4. But I can't change the ratio of the atoms, so I got to do that to all of them. Right? So times 4, times 4, times 4. So then that's going to be 9 carbons, 8 hydrogens, and 4 oxygens. And I can't simplify those, so I know I didn't do anything wrong. And so then my formula is C9H8O4. And that's the empirical formula for aspirin.